So we will be solving a problem regarding histogram equalization. Histogram equalization. So let us first consider the problem. So it is given that suppose that a 3-bit image of size 64 cross 64 pixels has the intensity distribution as shown in the table below. So just understand the concept before solving the problem. So they are given that the given image is of 3-bit and is of size 64 cross 64, and the intensity distribution table will be given. So we need to perform histogram equalization. So the table is, so if you consider the table, so if you consider the table, so they will be giving the intensity and its distribution. First intensity, the intensity is given by Rk and its distribution is given by Nk. So since it's a 3-bit image, okay, since it's a 3-bit image, the number of levels, okay, the number of levels which will be called as L will be given by L equals 2 to the power of k, where k is nothing but number of bits used to represent the image. Here the number of bits is 3, so we'll be having levels equals 2 to the power of 3, which is equal to 8 levels. So there will be 8 levels of intensity. So the 8 levels of intensities are 0, 1, 2, 3, 4, 5, 6 and 7. So these are the different levels. So you are having 8 levels since it's a 3-bit image. Okay. Understand the logic properly. So now you have the intensity values, so that is different levels. Now we need to consider the distribution. Again the distribution is given here. So before considering the distribution, let us consider how many pixels are there. So it is given as 64 cross 64 pixels. So this is the number of rows which is indicated by m, and this is the number of columns which is indicated by n. So your m cross n will give you the total number of pixels. So that is 64 cross 64, so which is nothing but 4096. So there are totally 4096 pixels. Each pixel will be having some particular intensity. Now let us consider the distribution of these pixels. So out of 4096 pixels, 790 pixels will be having intensity of 0, and 1023 pixels will be having an intensity of 1, and 850 pixels will be having an intensity of 2, and 656 pixels will be having an intensity of 3, and 329 pixels will be having an intensity of 4, and 245 pixels will be having an intensity of 5, and 122 pixels will be having intensity of 6, and 81 pixels will be having an intensity of 7. So when we add up all these pixels, it would be equal to, obviously it should be equal to 4096. That is the total number of pixels. So this is the amount of information which is given in the table. So you are asked to perform histogram equalization. So before performing histogram equalization, we just need to draw the histogram of this image. Okay, before performing histogram equalization, we just need to write the histogram of this image. Okay, so in order to write the histogram, you know that histogram is nothing but it is the plot of RK, is nothing but it is a plot of RK versus probability of RK. Okay, there is nothing but RK versus probability of RK. The value of RK is already given in the table, but the probability of RK is not been given. So in order to plot the histogram, first we need to find the values probability of RK. Okay, so let us consider this as probability of RK. So it is given by Nk divided by M into N. So a probability of RK is nothing but we are trying to normalize this values. Okay, so that is Nk divided by Mn. So here the values, so here the probability of 0 is, so it is nothing but 790 divided by, so that is Nk, 790 divided by M cross N. So you already know that M cross N is 4096. So the value would be, when you divide this, so the value would be 0.19. Okay, similarly here the value of Nk is 1023, so it is 1023 divided by 4096, so its value would turn out to be 0.25. So you observe here when you divide 1023 by 4096, so the value would be 0.249. Only two decimal points are sufficient. So in order to write that, we'll be considering the value of this. If it is greater than 5, we'll be rounding this to the next digit. So we have taken this as 0.25. Okay. If this number was less than 5, it would have been rounded up to, or else if it was, let us consider it was, let's consider this was 0.243. If this was the case, the number was, if it was 0.243, we would have written here as 0.24. Since it is 0.249, we are writing this as 0.25. Okay, clear with that? And next, we'll be doing the same operation, that is 850 by 4096, 656 by 4096, and similarly we'll be performing the same operation on all these values, and it will be getting the value of probability of RK. Okay, so this is the value it should be getting: 0.21, 0.16, 0.08, 0.06, 0.03, and 0.02. So now we have found out the probability of RK. So now we have RK and probability of RK. So with the help of this, now we are able to write the histogram of the image. Now let us draw the histogram of the image. So this is RK. So this is your RK, and this will be your probability of RK. So know that in order to draw the histogram, we require RK, and here it is probability of RK. So RK means different intensity levels of the input image: 0, 1, 2, 3, 4, 5, 6, and 7. So here you are having different values. Let us consider as 0.05. Let's consider step size of 0.05, 0.05, 0.10. Next, 0.15. Next, 0.20. Next, 0.25. 0.25. Now you know that 0, RK0 is having a probability of 0.19. So 0 is having a probability of 0.19. Next, 1, okay, 1 is having a probability of 0.25, 0.25. Next, 2 is having a probability of 0.21. So 2 is having a probability of 0.21, and 3 is having a probability of 0.16. 0.16. Next, 4 is having a probability of 0.08. So there is having a probability of 0.08, and 5 is having a probability of 0.06. and 6 is having a probability of 0.03, and 7 is having a probability of 0.02. Okay, so now we have plotted the histogram. Okay, so this is the histogram of the given image. Okay, this is the histogram of the histogram. So this is the histogram of the given image. This is histogram of the given image. Now what we need to do is we need to equalize this histogram. Okay, that is called as histogram equalization. So in order to equalize this histogram, in order to equalize this histogram, so what we need to do is we already have value rk. We need to apply some transformation on this rk. When we apply some transformation on this rk, we'll be getting the output as s. Okay, so this is what we'll be doing in order to get the equalization of this histogram, which is called as histogram equalization. So transformation is nothing but we'll be applying some formula so that it transforms this intensity of rk. So the formula is given by L minus 1 in L minus 1 into summation of j equals 0 to j equals 0 to k probability of PR of Rj, PR of Rj. So that is the formula. Okay, that is the formula which we need to find out. So here the value of L is, just look over here, the value of L is 8. So L equals 8. So there are 8 levels, 0 to 7. So the output also will be having 8 levels, that is 0 to 7. We need to calculate for all the 8 levels. So let us start with S naught. So S naught, S naught equals L minus 1 means is nothing but 8 minus 1, which is 7. Summation j equals 0 to, so the value of k is 0, so this would be 0. PR of Rj. So that is nothing but what? 7 into PR of R0. So just expanding this summation symbol, which is equal to 7 into, you just look the probability of R naught. The probability of R naught is how much? 0.19. So 7 into 0.1, 0.19. So that would give you 1.33. So sk equals, it is s0 equals 1.33. Similarly you calculate for s1. Now it is again L minus 1 is 7. Here the summation is from 0 to 1 since value is k. So it is PR of Rj. So it is 7 into, expand this summation symbol, that would be PR of R naught plus up to PR of R1. So that would be 7 into, so probability of R naught, you know that it is 0.19 0.19 plus we need to find probability of R1. So probability of R1 is 0.25. So it is 0.0.25. So that would be 3.08. 3.08. So S1 equals 3.08. Similarly, you need to calculate for S2. So S2 equals 7 into up to how much? Summation is till 2, 0 to 2. So that is 0, 1 and 2. So it would be probably that is PR of R0 plus PR of R1 plus PR of R2. So that is nothing but 7 into 0.19 plus probability of R1, you already know that it is 0.25 plus probability of R2, it is 0.21. 0.21. So that would give you the value of 4.55. 4.55. Similarly, if go on calculating up to S7. So when you do that, the value of S3 would be 5.67 and value of S4 would be 6.23. Next, value of S5 would be 6.65. Value of S6 would be 6.86 and value of S7 would be 7.0. So now by applying transformation to RK, you have converted that to SK. Now you are having value of RK and value of SK. So this is nothing but transformation function. We call this as a transformation function. This is a transformation function. Now let us plot RK versus SK, which is nothing but a transformation function. So let's consider this as RK and this as SK. So this is your RK and this is your SK. At input you add 8 levels 0 to 7. So add this as 0, 1, 2, 3, 4, 5, 6 and 7. Next SK we got S0 is 0, 1.33, 3.08, 4.55, 5.67. So we're having till 7. So starting from 1.33. So let us consider a step of 1. Let us consider step size of 1.4. This is 1.4, 2.8, next 4.2, next 5.6, and 7.0. And now if you plot these, so the S0 is 1.33, so it is somewhere around 1.33. S1 is 3.08, S1 is 3.08, S2 is 4.55, so it is 4.55. Next S3 is 5.67, so it is 5.67. Next S4 is 6.23, 6.23. Next S5 is 6.65, 6.65. So S6 is 6.86, 6.86. And S7 is 7, S7 is 7. So these are the plotted function. So if we consider carefully, so this forms an staircase waveform. So this forms the staircase waveform. Okay. So here, if you closely observe, the values of S0 is fractional value 1.33, 3.08, 4.55, 5.67, 6.23, 6.65, 6.86. Okay. So the value cannot be a fractional value. So what we need to do is we need to round off these values. So we'll be rounding off these values. So S0, which was 1.33, can be rounded off to 1. So if this value after the decimal place, if it is less than 5, we keep the number as it is. If it is greater than 5, round this to the next number. S0 is 1.33, it can be rounded off to 1. Next S1, so S0 equals 1.33. S1 was 3.08, so this can be rounded up to 3. Next S2, so this was 4.55, so since it is equal to 5, you can round off this to the next number, which is 5. Next S3, which is 5.67, so this can be rounded off to 6. Next S4, which is equal to 6.23, so this can be rounded off to 6. Next S5, which is 6.65, can be rounded off to 7. Next S6, 6.86, this can be rounded off to 7. Next S7, which is 7.00, this is kept as 7 itself. This is kept as 7 itself. So the fractional values is converted to integer value. Now we can perform the equalized histogram of the image. So if we clearly look over here at the input, there were 8 levels: 0, 1, 2, 3, 4, 5, 6, 7. So there are 8 levels here. Whereas in case of this, if you observe, 1, 3, 5, 6 and 7, there are only 1, 2, 3, 4, 5 levels. So the number of levels equals 5. So the 8 levels is reduced to 5 levels when we apply the transformation function. Now we need to plot the histogram of this image, which is called as equalized histogram. So it is a plot of SK versus, it is nothing but it is a plot of ESK versus a probability of SK. It will be graph of a plot of SK versus probability of SK. That will be called as histogram of the output image or equalized histogram. Now you have the value of SK, but you doesn't have the value of PS of SK. So in order to find the value of PS of SK, you have the formula SK divided by M into N. SK divided by M into N. So M into N is nothing but 4096, which is the number of pixels. But SK, here you are having the values of, that is different levels of values of intensity, but you doesn't know how much number of pixels are there with this particular levels. So you need to find that. Okay, so first is S0. S0 is what? 1. So if you observe here, 0. Okay, so 0, which is the value of R0. Okay, 0, which is the value of R0, is mapped to 1. Okay, is mapped to 1. So that indicates that R0 equals 0. R0 equals 0 was mapped to S1. Was mapped to S1, which is equal to, the level of that is, intensity level is 1. You know the intensity level, but you doesn't know the number of pixels with this. So you go in the reverse procedure. 1 means it is mapping to 0. So you look at the table which was given. So 0 means, so there are totally 790 pixels. So 1 was mapped to 0. So 0 is having 790 pixels. So there are 790 pixels. Okay, so there are 790 pixels. So there are 790 pixels. So there are 790 pixels with an intensity of 1. Next, let us consider R1. Let's consider R1, which is equal to 1. So that is your R1 was mapped to 3. Okay, was mapped to 3. So R1 was mapped to 3, which is equal to 3. So you need to find out the number of pixels. 3 means it was nothing but 1. Look at the table. 3 means 3 was mapped to 1. So 1 is having 1023. 3 was mapped to 1. 1 is having 1023 pixels. So considering here 3 was mapped to 1, so here it is having 1023 pixels. So it is having 1023 pixels. 1023 pixels. Next, R2 equals 2 was mapped to 5. That is S5. Mapped to S5. So we need to find out the pixels. So from here go to 2 and look at the number of pixels at 2. So number of pixels at 2 is 850. So I'll be writing here as 850. So I'll be writing here as 850 pixels. Next, R3, which is equal to 3, and R4, which is equal to 4, both are mapped to same value, which is 6. So R3 equals 3 and R4 equals 4. So both of them are mapped to as 6, which is equal to 6. Now the total number of pixels here would be the sum of pixels at 3 and 4. So at 3 and 4, it is 3 and 4, 626 plus 329. 6 56 plus 329 329. So that would be 985 pixels. 985 pixels. Next, R5, R6 and R7. R5, R6 and R7. R5, R6 and R7. Is mapped to S7. Is mapped to S7, which is equal to S7. So now you need to consider the pixels of 5, 6 and 7. So 245, 122 and 81. So it is 245 plus 122 plus 81. So that would be 448 pixels. So that will be 448 pixels. 448 pixels. So now you know the number of pixels, okay, that is the number of SK. Now you can find the probability of this. So first let us find the probability of S1, this one. So the probability of S1 would be probability, that is PS of S1. So that would be 790 pixels. So that is 790 pixels divided by 4096 divided by 4096. So that would be 0.1 Next, PS of S3. So that is 1023 divided by 4096. So that will be 0.24. Next, PS of S5, that is PS of S5. So that is 850 divided by 4096. So that would be 0.20. Next, PS of S6. So that is 985 divided by 4096. So that is 0.24. Next, PS of S7. PS of S7. So that is 448 divided by 4096. So that would be 0.10. So now you are having the value of SK, which is 1, 3, 5, 6 and 7. And also having the probability of that SK. Probability of S1, probability of S3, S5, S6 and S7. Now with the help of this, you can draw the histogram of this image. So the histogram of this image is So this is your sk, and this would be your psf sk. So at sk you just need to write down s0 s1 up to s7, 0 1 2 3 4 5 6 and 7. Next, PS of SK, let us consider an unit of 0.05, 0.05. Next, 0.10, 0.15, next 0.20, next 0.25. So now S0, there is no S0, so there is no S0. Next S1, so S1, its probability is 0.19. Its probability is 0.19. 0.19. Next S2, there is no S2, we need to consider S3. So probability of S3 is 0.24, so it is 0.24. Next, so probability of S3, probability of S3 is 0.24. Okay. Next S4, there is no S4. Next we need to consider S5, probability of S5 is 0.20, so it is 0.20. Next S6, so if consider S6, its probability is 0.24, is 0.24. Next S7, its probability is 0.10, so it is S7 is 0.10. So these are the values. So whatever the histogram you got here is called as equalized histogram. So this is nothing but equalized histogram. So it's called as histogram equalization. So it's also called as output histogram. Okay, you can also call this as output histogram. Okay. So earlier, so this was the histogram of the given image. When we apply a transfer function on that, we'll be getting this as the histogram. This is the modified histogram, which is called as histogram equalization. Okay, so this is very important problem. Just